we're going to talk about multiplying decimal numbers. Suppose you want to multiply 32.8 times 7.1. The first thing is you don't have to line up the decimals. This number is around, I don't know, 30, and this number is around 7. I rounded down on each number, and that's 210. So the answer should be a little bit more than 210. Well, rather than going 1 times 8, 1 times 2, 1 times 3, I know what 1 times 328 is. It's 328. Notice I didn't say 32.8. Just ignore the decimals for right now. Indent. Now I admit I don't know what 7 times 328 is. 7 times 8 is 56. 7 times 2 is 14. Plus 5 more is 19. 7 times 3 is 21. Plus 1 is 22. And when I add these numbers, I get 8, 8, 12, 3, 2. And I want my answer to be around 210. In fact, a little bit more, because I rounded down to 30 from 32.8, and I rounded down from 7.1 to 7. So obviously, I hope, the decimal goes there. Now, if you really hate the thinking method, here's the mechanical method. This decimal is in one place. That is, it's not here. It goes in 1. This one goes in another 1. 1 plus 1 is 2. So when we get our answer, we have to move in 2 places. But I hope you don't think it's hard to do 30 times 7. It's very similar to 3 times 7, but then add the 0. Okay, that's the first problem. Suppose you were asked to do 32.194 times 0.9. Well, this is around 32, and this is around 1. So we would expect our answer to be around 32. Now we ignore the decimals. 9 times 4 is 36. 9 times 9 is 81, plus 3 more is 84. 9 times 1 is 9, plus 8 is 17. 9 times 2 is 18, plus the 1 is 19. 9 times 3 is 27, plus 1 more is 28. Now, I'm just concerned about, okay. So, the number's supposed to be around 32. Okay, so the decimal goes there. If you want to see the mechanical way of doing it, this decimal is not here. It's in 1, 2, 3 places. This decimal is not here. It's in 1 place. When you add those places, you get 4. So the decimal's not there. It is 1, 2, 3, 4. It is right there. 28.9746. Let us try another problem. Suppose we have 0.0004 times 0.021. Now, here we have a problem. This number is around 0, and this number is around 0. And when you multiply a number around 0 by a number around 0, you'll get a number around 0. But here's a problem. I'm going to change this number. I'm going to make it 0.04, for example. And I'll keep the other number the same. So this product can't be the same as this product. This number is multiple times bigger. But you know what? This is around 1 and this is, around 0, and that's around 0. So the answer is going to be around 0. Problem is that if the answer turns out to be, I don't know, 3, 2, 1, 4, well, you can put a 0 in front to make it near 0. Or you can put 2 zeros in the front to make it 0. Or 3 zeros in the front to make it 0. And the problem is that I don't know which one to use. All I'm saying is if the numbers are around 0, you're going to have to use the mechanical method to find out where the decimal goes. Okay, now clearly 1 times 4 is going to be 4. Indent. Now you want to put in zeros, 1 times those zeros, put them in. But the bottom line is, that's 4. Now, you do 2 times this number. Well, 2 times 4 is 8. You want to put in some zeros, put in some zeros. You can even put in more zeros than you need. It's not going to matter. Now, indent twice. Now, 0 times this number is going to be 0. You can put 1 0. You can put 4 zeros. It's not going to matter. You get 4, 8, and then some zeros. Okay? Even if you had extra zeros, it doesn't matter. Now, since I wrote on the problem, let me write it down here. The first decimal is not here. It's in 1, 2, 3, 4 places in. And this decimal is in 1, 2, 3 places. 4 plus 3 is 7. So we need to move this decimal 7 places to the left. 1, 2, 3, 4, 5, 6. Look at this. If we didn't put these zeros up here, we still didn't have enough numbers. So what you need to do is go for sevens. And there's the decimal. If any one of these loops do not have a digit above it, like the last one, put it in. Okay, so what I'm saying is let's do it again. 0.0004 times 0.021. 1 times 4 is 4. You don't need to put the zeros. 2 times 4 is 8. Don't need to put the zeros. And then indent 2 times. And, 0 times 4 is 0. You don't even need that last row. You get 4, 8, and we have to move in 4 places and 3 places. 1, 2, 3, 4, 5, 6, 7 places. We have 1, 2, 3, 4, 5 zeros and then 84. 1, 2, 3, 4, 5 zeros and then 84. Okay, putting zeros in is not going to affect anything. Doesn't matter how many zeros you put. It's not going to affect anything. When you add these up with or without the zeros, you are going to get 84. And you're going to have to move in 7 spaces. And if you notice, even when we put in the zeros, we didn't even have enough zeros. We had to add that extra 0. Okay, let us try one more. So again, we knew it was going to be about 0, and 0.0000084 is about 0. But you know what? You may say, well, put the decimal there. That is also about 0. Absolutely. But we're not going to be able to tell whether it's this one or that one. without counting. Okay, if this number is about 0 and or this number is about 0, you have to count. If just one of them has to be near 0, and that causes trouble. Okay, suppose you want to do this. 72.312 times 7. Well, this number is around 70. This number, 7.4, let's make it, is around 7. 7 times 7 is 49 with that extra 0. Just make sure we get around 490. Okay, 4 times 2 is 8. 4 times 1 is 4. 4 times 3 is 12, carry the 1. 4 times 2 is 8, plus the 1 is 9. And 4 times 7 is 28. Now we indent, and now we do 7 times 1 is 14, carry the 1. 7 times 1 is 7, plus the 1 is 8. 7 times 3 is 21, carry the 2. 7 times 2 is 14, plus 2 more is 16, carry the 1. 7 times 7 is 49, plus 1 is 50. Now when you add these digits, 10, 11, 15, 3, and 5, our answer is supposed to be around 490. Well, I'd put the decimal right there. And to show you that I'm right, 7.4. This decimal, if it were here, I'd put a 0 here and then say this one went in 1. So the total would be 1. But it wasn't there. It was in, moved in 1, 2, 3 places. 3 plus 1 is 4. So I move in 4 places. 1, 2, 3, 4. But I knew what 70 times 7 was, so the decimal had to be right after the 5. You know, if I put the, let me write this down a few times, please. You know, if I put the decimal there, that's only 5.3, a little bit more than 5. If I put it here, that's a little bit more than 53. If I put it here, that's 5,351. None of these numbers, around 5, around 53, and around 5,351, are near 490. However, if I put the decimal here, this is around 535, which here, that is around 490, yes. This one is not near 490. This, I mean, if your boss owed you $490 and they paid you $5, I suspect you would complain. If your boss owed you $490 and paid you $53, I think you would complain. If your boss owed you, I take that back. Yeah, okay. If your boss owed you $490 and paid you $5,351, I think your boss would complain. If your boss owed you $490 and paid you $535, you know, maybe your boss would be whatever. It's only a few dollars more. It's not almost $5,000 more. Your boss pays you over around $5,000 more than he or she owes you. They're not going to be happy about that error. But, you know, they owed you $490 and they accidentally paid you $535. They're not going to complain. That is why this here is the reasonable answer. just like we said up here. You don't have to count in the positions unless a number is near 1. If you multiply in 0.003 by 7, okay, you can say, well, 7 times 3 is 21, and this is around 0 times around 7, or exactly 7. We get around 0. Yeah, absolutely. But is it 0.021? Is it 0.0021? Is it this? You can tell if a number is between 2 and 3. It's hard to tell which number is between 0 and 1 because the decimals are, you can have the decimals in different locations and they'll be between 0 and 1. But if we had 23, if we have this number, and the answer is supposed to be around 240, or let's just say 2. So then the decimal goes there. The answer is supposed to be around 20, then you put the decimal there. The answer is supposed to be around 1. Do you put the decimal here? Or do you put the decimal there? There's many choices. Okay, so this problem that I just put up, we have to do. We have to do this problem. And we'll get an answer near 0. 7 times 3 is 21, carry the 2. 7 times 0 is 0, plus 2 is 2. And 7 times 0, it is up to you whether or not you put the 0. Now, let's just write down the numbers again. This decimal is right here, so it didn't move in any. If there's no decimal, it's always understood to be to the right. This decimal went in 1, 2, 3 places. 3 plus 0 is 3. So I need to go in 1, 2, 3. So I need that 0. And that would be the answer. Again, that number is also near 0. That number is also near 0. 0 has the property where, if you're around 0, it has the property there where there's multiple places where you can put the decimal where it will be around 0 or close to 0. You have all those that are close to 0. But if this answer, 21, if it was supposed to be around 2, then we would say this becomes 2.1. If it was supposed to be around 20, then we'll say, oh, the 21 is really 210. If it was supposed, I meant 21. If it was supposed to be around 200, then I would say the 21 should become 210. Only one answer. If it's supposed to be around 2000, then I would say the 21 becomes 2100. Okay, why? Because I moved the decimal 1, 2 places. But when it comes to 0, when it comes close to 0, 21 becomes I don't know. Okay, I don't know. All of these numbers are close to 0. And all I did was move the decimal. But if it's close to 2, I know where the decimal goes, 2.1. If it's close to 20, I know the answer is just 21. Close to 200, 210. Close to 2000, 2100. But if it's close to 0, I don't know. Here, one of the numbers, this number was close to 0, and that was not. But I still don't know the answer. So You have to count in if one of the numbers is near 0. I don't want you to say, oh, did this person on YouTube said just round, approximate, 7.31 times 0.001. This is around 7. This is around 0. The answer should be around 0. And 1 times that number is 731. And if I'm going to be near 0, I'll put the decimal there and be done. No, maybe the decimal goes here. Maybe the decimal goes here. Maybe the decimal goes there. All of these numbers, except maybe this first one, they're around 0. They're around 0. You have to count in. 1, 2, 3, 4, 5. 1, 2, 3, 4. No. 1, 2, 3, 4, 5. There it is. There's your answer. 0.00731. You can't do it without counting. And how did you know this? Because one of the numbers was near 0. Now that doesn't mean that if you multiply by 0.9, that's around 1. And this one's around 7. The answer should be around 7. 9 times 1, 9 times 3 is 27. 9 times 7 is 63. Plus 2 more is 65. I'm supposed to be near 7. I put the decimal right there. Just thinking for a moment. Okay, yeah, that answer does seem reasonable. Okay, but I put the decimal where it was near 7. That I knew where the decimal should go. I was just shocked that it wasn't a little bit bigger than that number. That is, I had to check my arithmetic. Okay, that completes this section on multiplying decimal numbers.